Welcome to the lecture on regression analysis. In this lecture, I am going to discuss about what is meant by regression and how to find the regression lines, and also how to find the correlation coefficient by using the lines of regression, and how to find means of the regression lines. So first we will see what is meant by regression. So regression is an estimation of one independent variable in terms of the other variable. So here I am taking two independent variables, that is x and y. So we are going to represent the one independent variable in terms of the other variable is called the regressions. So first one, regression line of y on x. So we'll see how to represent the independent variable y in terms of the independent variable x. The formula is y minus y bar is equal to r into sigma y by sigma x, x minus x bar, or capital, we can use capital Y also, because we know that the capital Y value is nothing but y minus y bar and capital X is given by x minus x bar. So we can represent the lines of regression by using this formula also, that is capital Y is equal to summation capital X capital Y divided by summation x square into capital X. Next is regression line x on y. So we'll see how to represent the independent variable x in terms of y. The formula is x minus x bar is equal to or sigma x by sigma y into y minus y bar, or in terms of capital X and capital Y is x is equal to summation xy divided by summation y square into capital Y. So in the above two equations, the coefficients of x and y is, so in the first equation, the coefficient of x is r sigma y by sigma x. In the second equation, the coefficient of y is r sigma x by sigma y, are known as regression coefficients. So now, we'll see how to estimate the correlation coefficient by using the lines of regression. The formula is like this: r is equal to plus or minus square root of coefficient of x into coefficient y. So from the lines of regressions, so we have to take the values of coefficient of x and coefficient of y. We have to replace here to get the correlation coefficient value. So, and here we have to observe that r will be positive if both the coefficients of x and y is positive. So if both x and y coefficients are positive, we can write r is a positive correlation coefficient. If r is negative, only if both the coefficients are x and y is negative. So if both are negative, we can take r is a negative correlation coefficients. So now we will see few examples related to the lines of regression and how to find the correlation coefficient and also the means of x and y from the lines of regression. So the problem is like this: find the following data regarding the heights and weights of 100 college students are given. So summation x is 15,000, summation y is 68,000, summation x square is 2272,500, summation y square is 46302y, summation xy is 1022,250. So find the correlation coefficient between height and weight and state the equations of regression of height on weight. So we have to find the correlation coefficient and also we have to find the lines of regression. So first we will find the correlation coefficient. So since the data is given in terms of x and y, so first let me find the values of x bar and y bar. So we know how to find mean of x. So take summation x divided by n. So the value will be 15,000 divided by 100 I will get. So since the given data is for 100 college students, so n will be 100. So x bar will be 150. Similarly, we have to estimate the value of y bar also. So y bar is given by summation y divided by n. So replacing summation y as 6800 divided by total number of students, I will get 68 is the y bar. So sigma x formula will be already we know that it is given by square root of summation x square by n minus summation x by n whole square. So it will be equal to square root of 2272,500 by 100 minus 15,000 by 100 whole square. So on simplifying the equation, we'll get the standard deviation on x series is 15. So similarly we find sigma y, that is standard deviation with respect to y. So we will get square root of sigma y square by n minus sigma y by n whole square. On replacing the data, we'll get square root of 463025 by 100 minus 6800 by 100 whole square. On simplifying this, we'll get the standard deviation with respect to y is 2.5. So now we can find the correlation coefficient very easily. So the formula for correlation coefficient is r is equal to n summation xy minus summation x into summation y divided by square root of n into summation x square minus summation x whole square into n summation y square minus summation y. Since we have all these summation values and n values, I can replace the values in the equation. So on simplifying the equation, I will get the value of the correlation coefficient is 0.6. Since we got the value of r, we got the sigma x value, we have the sigma y value, and also we are having y bar value and x bar value also. So now regression of height on weight, that is y on x, will be given that y minus y bar is equal to r sigma y by sigma x into x minus x bar. So on replacing the data like y bar, x bar, r, sigma y, sigma x here, I will get the equation like y minus 68.6 2.5 by 15 into x minus 150. On simplifying the equation, we will get the equation like y minus 68 is equal to 1 by 10 x minus 150. So on further simplification, by taking 10 to LHS, I will get 10y minus 680 is equal to x minus 150, or 10y is equal to x plus 530 is the required regression of height on weight. So we'll see one more example on the lines of regression. The two regression equations of variables x and y are x is equal to 19.13 minus 0.87y and y is equal to 11.64 minus 0.50x. So from this equation, we have to estimate mean of x and mean of y, and also we have to find the correlation coefficient between small x and small y. So first we will see how to find mean of x and mean of y. So it's very easy. So take the given lines of equations x and y on x. So given that x is equal to 19.13 minus 0.87y, y is equal to 11.64 minus 0.50x. Call this one as equation number 1. Suppose if I assume that the equation 1 passes through the point x bar and y bar. I mean it is passing through mean of x and mean of y. So I can change the variables x and y in terms of x bar and y bar. So I will get the equation like x bar is equal to 19.13 minus 0.7 y bar is equal to 11.64 minus 0.50 x bar. On simplifying these equations, I will get x bar plus 0.87 y bar is equal to 19.13 by shifting that y bar to LHS. Again, y bar 0.50 x bar plus y bar is equal to 11.64. On shifting that minus 0.50 x bar to LHS, I got the equations like this. So now in the calculator, go for equation mode. Since we are having two unknowns, x bar and y bar. So replace the values in the two unknowns equation. On simplifying the equation, we'll get x bar is equal to 15.93 and y bar is equal to 3.67. So we can conclude that mean of x is 15.93 and mean of y is 3.67. So now let me see how to find the correlation coefficient from the given lines of regression. So the formula to find the correlation coefficient from the lines of regression is plus or minus coefficient square root of coefficient of x and coefficient of y. So in the problem, the given lines of regression are x is equal to 19.13 minus 0.87y, y is equal to 11.64 minus 0.50x. So here I can choose the coefficient of y is minus 0.87, coefficient of x is minus 0.50. So if I replace both the values in the equation, I will get plus or minus square root of minus 0.50 into minus 0.87. So on simplifying this, we'll get r is equal to plus or minus 0.6595. Since both are negative here, both the coefficient of x and coefficient of y are negative, so r will be minus 0.6595. So this is a solution for the correlation coefficient from the lines of regression. So try to solve more problems by seeing question bank or gravel book. So if you got any doubt means please give a comment in the inbox so that I can respond for your doubts. Thank you.